All right, so this is now composite functions, and I am going to start by looking actually not at A, but I'll probably go all the way here to C first, just so that I think it's a little bit easier when there's numbers involved, like 25 and 36. This is done exactly the same way. So I notice that 25 is a perfect number, 36 is a perfect square. Sorry, 25 and 36 are perfect squares and a minus sign in between. So what we need to do is 25 is 5 and 5. 36 is 6 and 6. One needs to be plus, one needs to be minus. And then this needs to be x minus 1 and x minus 1, because x minus 1 times x minus 1 is x minus 1 squared. And this side needs to be x plus 3 and x plus 3, because x plus 3 and x plus 3 is x plus 3 squared. So that's basically all there is to it. This diagonal is a negative 30 x minus 1 x plus 3. This diagonal is a positive 30 x minus 1 x plus 3. And if you add those, you're going to get a 0, x minus 1 x plus 3. 0 times anything just makes it disappear, which is why my middle term has completely disappeared. So I've factored this completely. So I've got a 5 x minus, I like to put, because I've got brackets here, I forgot, I think I did this, but I make them square brackets just because I've got round brackets. So I'll do square again here. 5 x minus 1 plus 6 x plus 3. That's one factor. Great, I've left myself not enough room. And then the other one is 5 x minus 1 minus 6 x plus 3. So I'm just going to erase this part over here. And normally that's where we would just kind of end things, but now we need to do, I don't know, some kind of grade 9 math. So in this you get a 5x minus 5, 6x plus 18. Here you're going to get a 5x minus 5, negative 6x minus 18. And then I can combine like terms. 5x and 6x get me an 11x. 18 minus 5. 18 minus 5 is going to be 13. And then 5x minus 6x is a negative 1x. Minus 5 and minus 18 is a minus 23. So there's a lot that went on there. I do realize that. But the basic part was 25 is 5 and 5. I needed x minus 1 squared, so x minus 1 times x minus 1. 36, 6 and 6, one of them has to be negative. And then instead of just x's or y's, it's an x plus 3 and x plus 3. That gets me an x plus 3 squared. My diagonals were negative 30 and positive 30, which got me a 0. So I just wrote them out here. Brought in the 5, brought in the 6, brought in the 5, brought in the 6, combined some like terms. So that's everything. Let's try that again. If you didn't get that, that's okay, because we've only done one example. There's like 9 or 100 or something. I don't know how many are here. So this is 3. 3 and 3. There's a 1 here, so I'm going to do negative 1 and positive 1. I know it's a perfect square. 9's a perfect square. 1's a perfect square. There's a difference in between, so this is a difference of square questions. I'm missing the middle term. There's only 2 terms here. There's 1 term and then 2 terms, so there's only 2. And then this side needs an x plus 2 and an x plus 2 to get an x plus 2 squared. This side needs an x minus 1 and an x minus 1 to get an x minus 1 squared. This diagonal is negative 3. This diagonal is positive 3. If you add them, you get a 0. So I've got that and I've got that. So I'm actually going to do this. I'm going to write this. I'm going to write this as 3x plus 6. 3x plus 6 minus 1x. Negative 1 times negative 1 is plus 1. And then we've got a 3x plus 6. And then a 1x minus 1. Now I can combine like terms. 3x minus 1x is a 2x. 6 plus 1 is a 7. 3 plus 1 is a 4x. 6 minus 1 is a 5. So this is now considered fully factored. Again, there's not much to this. 9 was just 3 and 3. -1 was -1 and +1. Then I just wrote, because it's x plus 2 squared, I wrote x plus 2 and x plus 2, x minus 1, x minus 1, and then that's factored. So I just brought in the 3's, brought in the -1, brought in the 1, and then added like terms. So if you defreeze it here to copy it down, you can go ahead and do that. And then this one, I'm going to add 1's here. So let's factor this. 1 is a perfect square, which is 1 and 1. -1 is a perfect square. -1, +1. This is a difference of squares again, because there's only 2 terms. There's this term. Whoops. There is this term and this term. If you only have 2 terms and there's a minus sign and they're perfect squares, it's a difference of squares. This side normally would just be x and x, but here it's an x plus 1 and an x plus 1. Here it's an x minus 1 squared, so I have an x minus 1 and an x minus 1. So my diagonals are going to be 1 and -1. Right, so this side would be 1, x plus 1, x minus 1. And this side would be -1, x plus 1, x minus 1. That gets me a 0, x plus 1, x minus 1. And that 0 times anything is just 0. We don't write it, and which is why it's not even written down. So these are my 2 factors. So I've got a 1x plus 1. And a -1x and a +1. And then I have a 1x plus 1. And then a 1x minus 1. So 1x minus 1x is 0. 1 plus 1 is 2. So this is just a 2. 1x plus 1x is a 2x. 1 minus 1 is 0. So this 2 times 2x, but this is factored, but it even could be simplified. This would be 4x. So all of this mess turns out just to be 4x. So this is it in factored form, but we can simplify it even further to 4x. So I'm going to do the next questions. These are a certain type, I think. Yeah. So these are difference of squares. So if you wanted to label it, you could do that. These are these are composite functions. There's a title there. It's composite functions, but these ones are difference of squares. These ones down below will be something different. They're just normal trinomials. So there it is. And go ahead and make some notes. Again, if you want later versions, those are already online.